The load prediction app was split into two parts to help us understand how battery energy storage systems respond to real-world charging patterns over their life cycle. The first part uses BESS and electric car characteristics to predict load patterns over 24 hours, and the second part uses queuing theory to predict lineup formation at MERB EV facilities.
The need for the future load prediction application is simple. Electric vehicles drain a lot of power from the grid when they are charging. This is where the battery energy storage system, or BESS, comes in to provide extra power, helping to avoid loss of power to the other units in the building. The load prediction application predicts the charging and discharging of the BESS based on its initial charge and conditions. This application also tracks how many cars are lining up to have their vehicle charged throughout the day. There are a limited quantity of level 2 and level 3 chargers at any given charging station. If all the chargers are in use, then a lineup or queue will begin to form. The application uses queue theory to send cars to the fastest available charger to ensure that there are more chargers available to customers in times of high demand.
All right, so to determine the load on the MERB's electricity infrastructure on an hourly basis, we looked at the following parameters. The BESS charge time, discharge time for both level 2 and level 3 chargers, number of chargers used for both level 2 and level 3, and their respective percentage of utilization. The stated charge of the BESS, which ranges between 10 to 90%, average utilization rates of MERB's facility, and finally MERB's EV traffic over a 24-hour period. So through numerical calculations and sensitivity analysis, the following is our predicted output. So the graphical visualizers of the worst case scenario where we assume the chargers are under constant use. We have an average scenario where we display a predicted day-to-day usage of the chargers, as well as a best case scenario where we assume the chargers operate with middle utilization. We also output a graphical visualization of the lineup patterns that include a realistic case that displays lineups based on predicted parameters on an average day.